So we are starting to graph our polar equations, and I give you this polar equation, r equals 3 plus 3 cosine theta. Now, you might not know what this looks like, but there's a couple strategies we can use. So before, we could give you a graph like y equals x squared plus 5x plus 7 or something like that. And if you don't know exactly what that graph looks like, you can always plot points to kind of help see the shape. So when we start to graph these polar equations, we could plot some points to kind of see what the graphs look like. So now we need to understand those that we're not plugging in x and y's, we are having our points are r's and thetas. So we are going to plug in theta measures to get out our r values. And using this equation, we have 3 plus 3 cosine theta. So we're going to plug theta measures in for cosine. And so we want to pick points that we kind of know. So that's why we're going to pick our points from our unit circle, and they're going to help us to create this graph. So I started this first one. So if I have this, I'm going to plug in the point 0. And this first column is just as a guide for me that I know cosine of 0, so when I plug 0 in here, equals 1. So I can replace this equation with 3 plus 3 times 1, because that cosine of theta, or cosine of 0, is just 1. Get 3 plus 3 equals 6. And we can continue to do that for the remaining points here. So if you want some practice plugging these points in to make sure you know what they are, you can pause the video here to plug those points in, and then I'll go over them in a second. Alright, now that you had some time to pause, these are the remaining points. So we know that like pi over 4 is root 2 over 2. So when I plug that in, I'm going to get a decimal out, so I just approximated it to be 5.12. When you have pi over 2, cosine of pi over 2 is 0, and then I get that point equals 3 when I plug 0 in. Negative root 2 over 2, I am getting another approximated value. And if you kind of see, there's a little bit of a pattern here. We kind of see some repetition in these points, some positive, some negative, and we kind of know that coming from the periodic property of our cosine and sine functions. So good. So now we are going to go ahead and start to plot these points. So I have a polar graph on the side. So I'm going to start by just plotting the points. So I have my theta is 0. So that means I'm on this line, theta is 0 or 2 pi, and I go out 6 units. So each ring is 1 unit. So I'm 1, 2, 3, 4, 5, 6. So I have a point at 6, comma 0. Then my next point is on pi over 4. So my pi over 4 is this angle here, so it's coming from here to there. And I'm at 5.12. So I can definitely go out 5 rings. 1, 2, 3, 4, 5. And it's 5.12, so we're a little bit above it. Right about there. Then, when I'm at pi over 2, remember that's the straight up and down. That's our at this axis right here. And we're at 3 units. So 1, 2, 3. 3 pi over 4. So remember that cosine of 3 pi over 4 is negative root 2 over 2. But when we plug it into this equation, we still get a positive value. So 3 plus 3 times negative root 2 over 2, we get positive 0.08. So when I'm at 3 pi over 4, I'm not even at 1, so I'm going to be down here. Then when I'm at cosine of pi, so now I'm at this line, I have a radius of 0, so I haven't moved at all, so I'm actually still at the pole there. And now I'm at 5 pi over 4 is this line here, and I'm going to again go out that 0.8, so not quite at 1. Cosine 3 pi over 2 is 0, so that means in my equation I get a 3, so I'm at the point 3 down here. 7 pi over 4 is this line, and I'm going to be at 5.12 approximately, so 1, 2, 3, 4, 5. Then I finish out at 2 pi, which is the same as 0. I'm going to be at 6, and I already have that point there. So we have this graph, and now we're going to go ahead and try and connect these points. And bear with me as I try and do this on my trackpad. I don't have a stylus, so. So that is our general shape of this polar equation. And a couple cool things to notice is that we do see some symmetry here. If I had the line, kind of the horizontal line, there's some symmetry here. Right through that point. So the graph does kind of fall over, and we do notice that with the periodic property of it. So a lot of these graphs do have some symmetry, so it's kind of cool to point them out as is. And obviously, if we plugged more points in, we'd be able to see more of these points. So I'm going to go ahead and show you the calculator version of this. So if we pull up our calculator, we want to make sure we go first, we want to go to mode, make sure we are in radian mode. If you do all this and you don't get a nice graph, you might want to check to make sure you're in radian. And then we're not a function anymore, we're in polar, so I want to go over to polar, press enter so that's highlighted. And then when it does that, it already changes my graph. Instead of y, it now becomes r. So I'm going to go ahead and type this equation in 3 plus 3 cosine. And the same variable button is a theta now because the graph knows we're in there. I'm going to have my window. I'm going to go from 0 to 2 pi because those are the thetas we plugged in. You don't really have to change that theta step. I think that's good. We don't want our y min doesn't need to be that large, so we'll go negative 10 to 10. Same here. And if we graph, it went super fast, but we can kind of see we have a really similar picture. If my y max and min weren't as big, I think we'll see a little bit more flatter. Yeah, so that one looks a lot more. It's just because we stretched that y up and down. Alright, so that is how you graph a polar equation by hand.